Welcome to the lecture on Vedic mathematics. In this session, we will see techniques of squaring, square root, cube root, and I will teach you the base method of multiplication. The first technique that we are going to see is the technique of finding cube roots very fast. This technique is one of the best techniques of Vedic mathematics. In fact, the final answer will be obtained as quickly as 2 to 3 seconds. And we are going to solve cube roots of advanced numbers. Students giving competitive exams will find this technique really useful. However, the cube roots that we are going to find are only of perfect cubes. We cannot take imperfect cubes with this technique. But don't worry, in most school and college exams, they will mostly ask you only perfect cubes. So for that, what we are going to do is, we are going to write numbers from 1 to 10 and we will also write their cubes beside them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The cube of 1 is 1, 2 is 8, 3 will be 27, 4, 64, 5 is 125, 6 is 216, 7 is 343, 8, 512, 9, 29, 10 is 1000. So these are the cubes of 1 to 10. Learning this list is compulsory. As long as you don't know this list, you will not be able to solve the cube roots. Now, what do we observe? When the cube ends in 1, the cube root also ends in 1. If the cube ends in 8, the root will end in 2. If the cube ends in 7, root will end in 3. Cube ends in 4, root will end in 4. 5 will be 5, 6 will be 6, 3 will be 7, 2 will be 8, 9 will be 9, and 0 will be 0. We are looking at only the last digits of each number. So once again I recall the list. If the number ends in 1, root will end in 1. For 8, it will be 2. For 7, 3. For 4, it will be 4. For 5, it will be 5. For 6, it will be 6. For 3, 7, 2, 8, 9, 9, 0, 0. So once we know the last digit, the process of calculating cube roots becomes very easy. Now we will take examples of 3 cubes and we will find out their answer. We will take difficult numbers. Suppose you want to find the cube root of say 262, 1, 4, 4. Next we will take 1, 2, 1, 6, 7. Last we will take 1, 1, 7, 6, 4, 9. We are going to find the cube roots of these 3 numbers. Now you must have seen we have taken very difficult numbers. These are complex numbers. Once you find the cube roots of these, you will automatically understand how to find the cube roots of simpler numbers. Now the technique says whenever a number is given to you, start from the right, count 1, 2, 3 and put a slash. So here 1, 2, 3 and we'll put a slash. Again here 1, 2, 3 and we'll put a slash. Again here 1, 2, 3 and we'll put a slash. So we have divided the number in 2 parts. Note, till now we have not got the answer. Now I will show you how quickly we can find the answer. What do we observe here? The number ends in 4. Therefore, the root will also end in 4. We have already seen when the number ends in 4, the root ends in 4. So here the answer will be ending in 4. So it is dash and ending in 4. What is here we don't know. Therefore we have put a dash. We only know that it ends in 4. Here the number ends in 7. So the cube root will be ending in 3. For 7 it is 3. So it will be dash 3. And here the number ends in 9, so the root will end in 9. Answer will be dash 9. Thus we have half the answer with us. Now let us go to find what will come in the dash. Once we know what is there in the dash, we will have the complete answer with us. To get the left hand part of the answer, we will take only this part of the number to the left of the slash. Here to the left of the slash, the number is 262. Now, if this were the number line, the number 262 would have come between 216 and 343, because 262 is bigger than 216 and smaller than 343. So it would have come between this and this, that means between 6 and 7. 262 would have come between 6 and 7. Now you must ask yourself, what is the smaller number? Out of 6 and 7, which is the smaller number? Smaller number is 6, so we put it here. We always put the smaller number over here. This is our final answer. So the cube root of 262,144 is 64. Next, here the number to the left of the slash is 12. 12, if this were the number line, would have come between 8 and 27, because 12 is bigger than 8 and smaller than 27. So ideally 12 would have come between 2 and 3. Out of 2 and 3, the smaller number is 2, and therefore we put the number over here. Answer is 23. And finally we take over here 117. 117 lies between 64 and 125, because 117 is bigger than 64, smaller than 125. Out of 4 and 5, the smaller number is 4. So we put the number 4 here and get the answer as 49. So you can see how quickly we got the answer. In fact, we have not done any intermediary step. Just by looking at the number, we can get the answer. This is the beauty of Vedic mathematics. Just by glancing at the number, you can in many cases get the answer. So with this, we complete the chapter of cube root. I will now take a few practice examples and then we can verify how much you have understood. Let us take 3 more examples. These are 3 perfect cubes that I have taken. Once again, we will start from the right, count 1, 2, 3 and put a slash. So 1, 2, 3 slash 1, 2, 3 slash 1, 2, 3 slash. Number ends in 9, so root will end in 9. Answer is dash 9. And 704, we will take only the left hand part, the part to the left of the slash. 704 will come between 512 and 729. Between these two numbers, 704 will come. So between 8 and 9, smaller number is 8. So we write 8 here. Answer is 89. Here the number ends in 6. So root will also end in 6. We put dash 6. Number 175 will come between 125 and 216. That means between 5 and 6. Out of 5 and 6, the smaller number is 5. So I put it here. Answer is 56. And here number ends in 7. So root will end in 3. Answer will be dash 3. And this number 2, it lies between 1 and 8, because 2 is bigger than 1 and smaller than 8. So out of these two numbers, 1 and 2, smaller number is 1. We take it 1 and write over here. Answer is 13. So ideally, we have all the 3 answers within a few seconds. After enough practice, you will be able to solve cube roots in your mind. I have my students who are in 4th standard, 5th standard, and despite of the fact that cube root is not there in their syllabus, they can solve such sums within 2 to 3 seconds. So this is the beauty of this technique. I hope you have liked it. We will now move on to the next chapter of square roots. the technique of solving square roots is very much similar to that of solving cube roots. So now it will be very simple for you to understand the fundamental concepts that we use in solving of square roots. Once again, we will write the numbers from 1 to 10 and put their squares beside them. Square of 1 is 1, 2 will be 4, 3 will be 9, 4 will be 16, 5 will be 25, 6 36, 7 49, 8 64, 9 81 and 10 will be 100. Most of the students know square roots by heart, so I don't think this list should be a problem for you, especially those who are 7th standard and above, and all the way up to those giving competitive exams are generally well versed with these basic squares. So now we observe that when the number ends in 1, the square root ends in 1 or 9. Your number ends in 1 and in 1, your number ends in 1, square root ends in 9. So if the number ends in 1, the square root ends in 1 or 9. If the number ends in 4, square root ends in 2 or it will be 8. So for 4 it is 2 or 8. For 9 it will be 3 or 7. For 6 it will be 4 or 6. Now for 5 it will be, and for 0 it will be 0. We are looking only at the last digit of the respective squares and their square roots. So if the square ends in 1, square root ends in 1 or 9. Square ends in 4, root ends in 2 or 8. 9 will be 3 or 7. 6 will be 4 or 6. 5 will be 5 and 0 will be 0. A simple way to remember these numbers is just to keep in mind that both these numbers add to 10. Your 9 plus 1 is 10, 2 plus 8 is 10, 3 plus 7 is 10 and 4 plus 6 is 10. So if you get one number, the other number is the complement from 10. If you have 9, then you have 1. If you have 8, you have 2. If you have 3, you have 7. And 5 is 5, 0 is 0. So now we have seen how to get the last digit of the square root. We will next move on to examples and we will see how to solve them quickly. Suppose we want to find the square root of the number, say 1681. This is a perfect square whose square root we are going to find out. This technique is used to find the square root of only perfect squares. Now, here we have taken numbers like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and besides them we have written their squares. Square of 10 is 100, 20, 400, 30, 900 and so on. This is just for explanation. You don't need to make such a key while solving any square. But because I am explaining it to you for the first time, that is why I have made this key. Now, we notice here that the number 1681 lies between 1600 and 2500. That means the square root of this number lies between 40 and 50, because 40 is related to 1600 and 50 is related to 2500. That means the answer lies between 40 and 50. Further, the number ends in 1. We have already seen that if the number ends in 1, square root ends in 1 or 9. So first we know that the number lies between 40 and 50, and then we know since the number ends in 1, the answer ends in 1 or 9. So between 40 and 50 are numbers like 41, 42, 43, 44, 45, 46, 47, 48, 49. But we need only those numbers that end in 1 or 9. So out of all these numbers, our only options are 41 or 49, because only 41 or 49 end in 1 or 9. Once again I'll repeat, 1681 ends in 1, so root ends in 1 or 9. Also it is between 40 and 50, so the possibilities are 41 or 49. We cannot take 42 because 42 ends in 2, and since the number ends in 1, we have seen the root ends in 1 or 9. So our answer could be either 41 or 49. One of these two is correct, we don't know which. Let us find out which is the correct square root. What do we observe now? Is 1681 closer to the smaller number 1600 or bigger number 2500? If it is closer to the smaller number, we will take smaller as the answer, and if it is closer to the bigger number, we will take bigger as the answer. In this case we see 1681 is closer to 1600, the smaller number. Therefore out of 41 and 49, 41 is smaller, and hence this becomes our answer. Now 7744. This is the perfect square. We are going to find its square root. This number, as we can see, lies between 80 and 90. 7744 is bigger than 6400 and smaller than 8100. Therefore, the square root will lie between 80 and 90. Between 80 and 90, between these two numbers. So we know this much, that the answer is between 80 and 90. If you are giving any competitive exam and only one alternative is between 80 and 90, you can straight away tick it as the correct answer. Next, what do we observe? Number ends in 4. Now we have seen if the number ends in 4, the square root will end in 2 or 8, because 2 2s are 4 and 8 8s are 64. 2 2s are 4, 8 8s are 64. So if the number ends in 4, square root will end in 2 or 8. Answer will be, say, 82 or 88. So either our answer is 82 or our answer is 88. Last, what we have to observe is 7744 closer to the smaller number or bigger number. In this case, we observe 7744 is more closer to the bigger number 8100. Therefore, out of these two, the bigger number is 88, and we take it as the correct square root. So even in this case, you see, we get the answer of a square root by just looking at the number. We are not doing any intermediary steps. Just by observing the numbers and their characteristics, we can get the answer of the square root straight away. After some practice, you will be able to find the square root of such numbers in your mind without the use of a paper or a pen. We will take the last example in this series, and I am sure by 3 examples you will be perfectly understanding the system. Last example we will take is 1521. Again, if you see 1521, it lies between 900 and 1600. Therefore, the square root is between 30 and 40. Number ends in 1. Therefore, root will end in 1 or 9. So we need such numbers. Those are between 30 and 40 and end in 1 or 9. Between 30 and 40 and ending with 1 or 9 are 31 or 39. So the answer is either 31 or 39. 1521 is closer to the bigger number 1600. It is closer to 1600, the bigger number. Therefore, out of these two, we take the bigger number as the answer. Out of 31 and 39, bigger number is 39. Therefore, 39 is our answer. So you can see we can get the square roots very easy without any intermediary step. For the base method, we will be requiring 4 steps, and I am copying all 4 of them. The first step says take the base and the difference. This is your step A. Step B says number of digits in right hand side equal to number of zeros in the base. In right hand side equals number of zeros in the base. Step C says multiply the differences and step D says find the cross answer. Now, by the word base, I mean a certain power of 10. It can be 10, 100, 1000, 10,000, 1 lakh, anything, but a certain power of 10. We will also see numbers where we don't take powers of 10, but mostly in this method, we take examples which are closer to a power of 10. Number of digits in right hand side equal to the number of zeros in the base. Answer we will get in 2 parts, left hand side and right hand side. Third is multiply the differences. Fourth step, find the cross answer. As we solve examples, all these steps will become evident. So I will simultaneously solve 2 examples and we will see how these steps come into play. We will take numbers which are closer to the power of 10 and we will find the product of both the numbers simultaneously. We will take numbers where there are different bases involved so that you can understand the concept perfectly. First example we will take is multiplying 9997 by 9993. And the next example we will take is slightly bigger. We will multiply I will explain all the steps very slowly so you can understand them perfectly. First step says find the base and the difference. I've intentionally rubbed off the steps from the board so that you can hear me properly and get the concept in your mind. Step A says find the base and the difference. Here both the numbers are closer to 10,000 because this number is 9,997. This is 9,993. So the base in this case will become 10,000. And here both the numbers are closer to 1 crore because the numbers are 99 lakh, 99,999 multiplied by 99 lakh, 99,999. So the base in this case will become 1 crore. So 1 and then 7 zeros after it. So we have found the base. Next we will find the difference. Difference between 10,000 and 9997 is 3 and 10,000 and 9993 is 7. Here the difference will be 1 and 1 because difference between these two numbers is 1. So step A is over. We have found the base and we have found the difference. Step B says number of digits in right hand side equal to the number of zeros in the base. Now answer in the right hand side and left hand side. We will have 2 parts, right hand side, left hand side. Here also right hand side, left hand side. So number of digits in right hand side equal to number of zeros in the base. Here in the base there are 4 zeros, 1, 2, 3, 4. So right hand side will be a 4-digit answer. And here in the base there are 7 zeros. So right hand side will be a 7-digit answer. So number of digits in right hand side equal to number of zeros in the base. That is your step B. Step C says multiply the differences. Once again I repeat, multiply the differences. In this case the differences are 3 and 7. When you multiply both of them, you have 7 3s are 21. But we need a 4-digit answer. So instead of 21, we will write 0021. And here it says multiply the differences, 1 1s are 1. But we need a 7-digit answer. So we will make it 000001. So step C is over. We have found the number of digits in the right hand side and also found the right hand part of the answer. The last step says find the cross answer. That's step D. Step D says find the cross answer. So in this case you will have 9997 cross we will take. So 9997 minus 7, that is 9990. Alternatively we can take 9993 minus 3. Again it will give us the same answer. So you can take it this ways or this ways, the answer will always be the same. Even in this example, 9999999 minus 1 will become 9999998. So this is your final answer. You could have taken this way or this way. In either case it would have given you the correct answer. So 9997 into 9993 is this, and the product of these two is this. Using Vedic mathematics we can get the answer in just one line. Think of the number of steps you would have required to multiply these numbers by the normal method. So we see the base method can give us the answer in just one line. Now we will see more examples and different situations where the base method can be used. Here both the numbers are closer to the base 1 lakh. And here both the numbers are closer to the base 1000. Next we see the difference between these two numbers is 20 each. Difference between 1 lakh and 99,980 is 20, and the difference in this case is positive. Difference between 1000 and 1002 is plus 2. Here the difference is plus 3. So in this case we have 2 negatives, this case we have 2 positives. So first step is done, we have found the base and the difference. Step B says find the number of digits in right hand side. Now we know number of digits in right hand side equal to number of zeros in the base. Here in the base there are 5 zeros. So here right hand side will be a 5-digit answer, and here in the base there are 3 zeros. So right hand side will be a 3-digit answer. Next we have to multiply the differences. In this case it will be minus 20 multiplied by minus 20, that is plus 400. Minus minus is plus. So our answer is 400, but we need a 5-digit answer. So we will make it 00400. Here plus 2 into plus 3 is 6, but we need a 3-digit answer. So we make it 006. Thus we have got half the answer. If while giving any competitive exam your half answer corresponds uniquely to any one of the alternatives, you can straight away tick it correct. But if it does not, you will have to find the whole answer. And your last step says find the cross answer. So in this case it will be 99,980 minus 20, or you can take upwards 99,980 minus 20. Either case answer will be same, 99,960. And here it will be plus 3. So 1002 plus 3 is 1005. Or as I said, you can take this way or this way. 1003 plus 2 is 1005. So we have both the final answers with us. 99980 square is 99960 00400, and 1002 into 1003 is 1005006. So Vedic mathematics helps you to get the answer of such numbers in just one line, and after practice you will be able to do even these sums mentally. It is possible, just requires some practice. Suppose you have to multiply, say, 950 by 950. Both these numbers are closer to 1000, so the base in this case will become 1000. Difference between these two is 50, and again difference between these two is 50. Number of digits in right hand side will be 3 because there are 3 zeros in 1000. Now, when you multiply the differences, as we do in step C, 50 50s will become 2500, but you can fit only 3 digits over here. Out of 2500, you can fit only 3 digits. So we will write 0, 0, 5 and carry over 2, as I have done here. 0, 0, 5 and 2. So your answer 2500 will come like this. And your cross answer, step D, says 950 minus 50. So 950 minus 50 is 900. Our final answer will become 900 plus 2, that is 902, and 500 as it is. So our final answer is 902500. Basically we are doing nothing. Since we are having a 4-digit answer, we are carrying the 4th digit from here to here. So the final answer is 902500. Suppose we have to multiply, say, 95 by 115. Since both the numbers are closer to 100, our base in this case is 100. The difference here is minus 5 because 195 is minus 5, and here the difference is plus 15. Now, number of digits in right hand side will be 2 because there are 2 zeros in the base. Your vertical multiplication or multiplying the differences will yield minus 5 into plus 15. Minus 5 into plus 15 is minus 75. This is our right hand side, and left hand part of the answer will be 115 minus 5, that is 110. Our final answer as of now looks like 110 and minus 75. However, we cannot have minus 75 in the final answer. Negative sign is not permitted in between. So to get the exact final answer, we will multiply 110 with the base, that is 100, and then subtract 75 from it. So this will give you 11,000 minus 75, that's 10,925. This is your final answer. 95 into 115 is 10925. Once again I will repeat, we multiplied minus 5 by minus 15, therefore we got minus 75 in the final answer, but it is not permitted. Therefore we multiply this with the base and subtract this from it. So 110 into 100 minus 75, that's 11,000 minus 75, that's 10925. This is your final answer. So we have seen different permutations and combinations with the base method. The base method can also be used for squaring of numbers. In Vedic mathematics, this rule is called the Yavadunam rule. Yavadunam rule helps us in squaring numbers quickly. Let us see how that can be applied. Suppose we want to find the square of the number, say 96. Now, this number 96 is closer to the base 100. Difference between 100 and 96 we will put in a box over here as 4. Now let us see how we can quickly get the square of 96. Very simple. From 96 you subtract 4 and put it over here. So 96 minus 4 is 92. Then we find the square of this number and put it here. Square of 4 is 16 because 4 4s are 16. So this is our final answer. The square of 96 is 9216. Similarly, if we want to find the square of say a 3-digit number, we can do it by the same method. Let us find the square of 988. Base is 1000. Difference between 1000 and 988 is 12, which we'll put in a box over here. So first, 988 minus 12 will become 976. This becomes left half of our answer, and for the right half, we'll have a 3-digit answer because there are 3 zeros. 12 square. 12 multiplied by 12 is 144. So the answer is 144. Therefore, the square of 988 is 976144. Sometimes we might have a number above the base. It can be squared using the same method. Suppose we want to find the square of 108. Base in this case will be 100. Difference for these numbers will be plus 8. So, very simple to find the square. 108 plus 8 is 116. And plus 8 square is, we need a 2-digit answer, 00. So, 2-digit answer. Plus 8 square is 64. Final answer is 11664. Therefore, you can see square of 108 is 11664. Number is 97. It is closer to 100. So, the base will be 100. And the difference between these two is minus 3. So, I put minus 3 over here. So, to get a final answer, we have 97 minus 3, 94, and 2 zeros over here. So, 2 digits in right hand side. Minus 3 square will be 9, but we need a 2-digit answer. So, we put it 09. Because minus 3 into minus 3 is 9, but since there are 2 zeros in 100, we need a 2-digit answer, so we make it 09. Final answer is 9409. Square of 97 is 9409. With this, we complete the base method of squaring. We have seen the base method of multiplication and all the varieties used in that, and we have also seen the base method of squaring and all the varieties in that. Theorem of Pythagoras is one of the most important principles of geometry, and school, college and students giving professional exams are often asked questions on these. I will teach you a technique whereby we can find out triplets of Pythagoras. I will explain to you what is a triplet. For example, if there is a triangle A, B, C, where angle B is 90 degrees, according to Pythagoras, if this side is 3 units, this side is 4 units, and this will be 5. Because 3 square plus 4 square is 5 square. We all know this, then there is no need to emphasize the theorem. What I mean by triplet is the values 3, 4, 5. The values 3, 4, 5 form a triplet by themselves. So often students are asked questions whereby they are giving two sides and asked to find the third, or given these two and asked to find this. So I will teach you a technique of Vedic mathematics whereby you can form a Pythagorean triplet if only one value is given. Even if one value is given, we can find the remaining two values. Suppose if only 3 is given, we can find both the values 4 and 5 such that a triplet is formed. This is very important for students who are giving entrance exams like CAT and other such exams on MBA and other professional exams where such questions are often asked in geometry section. First we will see how to find the triplet where the given number is odd. Odd numbers include numbers like 1, 3, 5, 7, 9, 11, etc. So if the number is odd, we use 3 steps. First, step says square it. Second step says divide by 2. And third step says round it off. Let us take an odd number and find the triplet. Let us suppose we take 3. When we square it, we get the answer 9. When 9 is divided by 2, 9 divided by 2, we get 4.5. And now step C says round it off. So we will round this off to the next higher number and the next smaller number. So if you round 4.5 to the next bigger number, you have 5. And when you round it off 4.5 to the next smaller number, you have 4. Now, these values 3, 4 and 5 are your triplet. Very simple. I will do it once again. Number is 3. When you square it, you get 9. 9 divided by 2 is 4.5. When you round off 4.5 to the next smaller and bigger number, you have 4 and 5. So 3, 4 and 5 form the triplet. Let us take a little higher number. We will take a 2-digit number. The number is 11. When you square it, value is 121. When 121 is divided by 2, we get 60.5. And when you round it off to the next smaller and higher number, it will become 60 and 61. 60.5 rounded off to bigger number is 64. 60.5 rounded off to smaller number is 60. So 11, 60 and 61 form the Pythagorean triplet. We have seen the case of odd numbers. Now let us see how we can find the triplets of even numbers. Suppose I want to find the triplet of one number which is 10. Now, what I do is very simple. I divide this even number until I get an odd number, and then I use the same procedure that we have used for squaring odd numbers. So when 10 is divided by 2, you get 5. Now I have an odd number, so I repeat the procedure that I have used for odd numbers. Square of 5 is 25. When you divide 25 by 2, you get 12.5. And when you round 12.5 to the next smaller and bigger number, you have 12 and 13. So 5, 12 and 13 have formed a triplet. But we want a triplet whose one value is 10. So we do the reciprocal procedure. Since 5 is obtained by dividing 10 by 2, we have divided this by 2 to get this. So now we multiply this by 2. Since it is divided by 2, here we will multiply by 2. 12 multiplied by 2 is 24 and 13 multiplied by 2 is 26. So this is our main triplet, the one that we wanted. 10, 24 and 26. So 10 square plus 24 square is 26 square. Let us take the example of one more even number. We will take one value as 12. We want to find a triplet whose one value is 12. So as I said, we will be dividing it by such a number that the final answer is odd. When you divide 12 by 4, you get 3, and 3 is a odd number. So we will be using the same steps that we use for odd numbers. Square of 3 is 9. 9 divided by 2 is 4.5, and when 4.5 is rounded off, we get values 4 and 5. So 3, 4, 5 is the triplet, but we want the triplet whose one value is 12. Now since we have divided here by 4 to get 3, we will multiply by 4. 3 4s are 12, 4 4s are 16, and 5 4s are 20. Thus this 12, 16 and 20 make a Pythagorean triplet. 12 square plus 16 square is 20 square. We can verify it. 144 plus 256 is 400. So with this we have seen how Pythagorean triplets can be formed.